Hi guys, so this is the second video of my channel. Last time we covered DeepSeek MLA, where DeepSeek reduced memory usage in attention, like 93% reduction memory. You can check it out. So today, the topic for today is DeepSeek GRPO, or Group Relative Policy Optimization. So this is the paper which we will be covering. So yeah, only the basics. Rest you can read it. It's a very good paper. Like it shows how using coding models with coding models and how it outperforms the other open source models out there like Minerva, Mistral, Lemma. The entire method flow and like how they make their data set, how like the DeepSeek math based model, how it outperforms other model, but mainly the topic for today is reinforcement learning. We'll be seeing this one is without the RL, and this is with RL, but in DeepSeek way. So how you're seeing like how we have improved the accuracy over here. So we'll be looking a bit into this, like how and why it happened. So yeah, you can check out this paper. It's a really good paper, quite insightful. So today we'll be covering GRPO, Group Relative Policy Optimization. The idea is simple. PPO needs PPO needs a separate critic model. So what happens is while you train your own base model and you're computing losses, PPO has also a critic model, and that also needs to be trained while back propagation. So GRPO eliminates this critic model completely. This is one change which is the game changer for open source models out there and helped DeepSeek build R10. So why reinforcement learning for LLMs? Like to without RL, a model just generates tokens. It doesn't know what to do, what is a good answer. To steer the model towards the correct path, we use math, coding, and reasoning as feedback. So the loop is simple. The model generates an answer, we score the answer, then we update the model to produce more good answers. This is RL in simple terms. So what PPO does? So PPO is on the standard method. The first is the actor, which is our main model, which we'll be training. And the second is critic. It is also a neural network. Its job is to predict the expected award. So because a model writes a long answer and gets one reward, we still need to know which parts of the answer helped. So the critic helps in this. Okay. So the positive advantage means to push towards that output, and negative means a push away from this. But the critic is expensive. So example, if you have a 7B model, the critic is also of the same size, 7B model. And because the critic is trained, it needs weights, its own gradients, its own optimizer states, and activation. For example, just a 7B critic in FP16 has around 14 GB of weights. Adam optimizers can add around 56 GB. So before counting everything, you can easily reach around 70 GB of extra memory. So this is the pain point. So GRPO asks like, can we remove this critic? So what GRPO removes? Let's see. Its job is to kill the critic. So there's no separate value model, no losses gradient optimizer backdrop, back propagation. The model still has policy loss, the probability ratio, and like the clipping and KL penalty. These are all the terms which you can find in the paper. Where's the equation? Uh, yeah, this one. So yeah, so the job over GRPO is it uses group. So how what's the main concept behind this equation? So what does GRPO calculate without critic? It uses the group itself. For one prompt, instead of generating one answer, the model generates multiple answers. For example, 8 answers. Then we score each of the answers. Correct answer gets 1, wrong answer gets 0 in case of maths. Now we calculate the group rewards. And answer gets this formula, answer reward minus group reward. Okay, that's the whole trick. Say 3 out of 8 answers are correct, then if we like Divide it, you'll get 0.375, right? This one. So the advantage you'll have is 1 minus 0.37, which is 0.625. So we push the model towards that answer. For a wrong answer, we push away. This is what it says, push away. So this is called group relative. The reward is absolute, right or wrong. But the advantage is relative, better or worse than the group. Okay. So the group becomes the baseline and there is no critic needed in this. So it's smart, like it's quite self-adjusting, the model. The if the group answer is average is 1, then each answer also has a reward of 1, so the advantage becomes 0. In that case, update is not needed. But that's not the case always, right? So yeah, GRPO removes the critic, but it keeps one important idea from PPO, the clip. Okay, we keep the clip from PPO. So it's the maths equation. If you want to go deep into it, you can read the research paper. So what it does is new probability. So uses a probability ratio. New probability divided by old probability. Then it clips this into safe range like 0.8 to 1.2. So if the reward says move fast, the clip says small steps only. Okay, so that we can move slowly towards optimization. Reward decides the direction and clip decides the maximum step size. Okay, to keep the training stable so that we don't have sudden jump in our model. So yeah, so this is the main idea. PPO uses a critic to estimate advantage. RPO removes the critic. That means less memory, there is fewer losses to train and fewer moving parts and a simple loop. Okay. So this was introduced in DeepSeek math and later become the key ideas for DeepSeek R10. So yeah, it leads to 50% memory saving, self calibrating baseline. It auto trains, right? Simple training loops, and because we don't have to optimize PPO. And yeah, this is what made R1 feasible. So thanks. In the next video, we'll be talking about R10, how reasoning started emerging from pure reinforcement learning. So thank you.